In our last lesson, we began talking about matter. How matter is made up of two kinds of things: pure substances and mixtures. I like to think of pure substances as individuals, people, and two kinds of people: parents and children. CMPD. Compounds. That is the abbreviation for compounds. CMPDS. Okay? So your parents would be elements. When they combined together, they created you. You are similar to your parents, but you are also very, very unique. A good examples of elements would be the elements hydrogen and oxygen. When they combine together, they will form the child water, H2O. Okay, so in our last lesson, I explained to you that a mixture is what I like to think of as a marriage. Why? Because in a marriage, you have two people that come together, and the husband is still the husband. He still maintains all his charming and irritating characteristics. And the wife is still the wife. She has all her properties and personality quirks, and just because they get married does not mean that any of those go away. So a mixture is going to be when you combine different pure substances together. So let's unpack that. Water is a compound, but the water that we drink is not a compound. What is it? It is a mixture. Now, if I was to give you distilled water, yes, that would be just H2O. But the water that you drink has all sorts of dissolved stuff in it. Stuff that they don't take out of the river or the lake where they get your water from, simply because it's not bad for you. Some of it is stuff that they add because it helps. For example, they may add some chlorine in order to kill any bacteria. They may also add some fluoride in order to help your teeth, make your teeth stronger. So your tap water contains all sorts of impurities, all sorts of other elements and compounds, some of which are completely harmless, some of which are added in order to help you out. So tap water is a mixture, while distilled water is a pure substance. So what is a mixture? Two or more substances that are combined, but they each retain their own properties. They each retain their own personalities. So, Kool-Aid is a good example. You have the water, and then you have the mix, and you put the mix in the water and you swirl it together, and you know what? It's just watery stuff. It's still water, and it's still Kool-Aid. It may look like something different, but that's just because they've kind of mixed together. And what happens if you allow the water to just evaporate? The Kool-Aid will stay behind. That's a key thing. With mixtures, you can get them separated. With a compound, you can't. With a marriage, is it possible for a marriage to end in divorce? Yes, unfortunately. But with a compound, if your parents were to get a divorce, can your dad says, well, I'm taking all my genes from Susie. And the mom says, fine, well, I'm taking all of my genes from Susie. No, they can't take their genes back from you. You are a unique new person. So a compound cannot be broken down physically, cannot be further subdivided. Neither can an element. But a mixture can be separated out easily. There are two kinds of mixtures: hetero and homo. Hetero is a Greek word that means different. And genius means stuff. Homo means the same, and genius means stuff. So, a heterogeneous mixture is made up of things that you can kind of tell where they're different. Look at this thing right here. There's like, it's some kind of spice or maybe some kind of food, but there's some dark spots and then there's some red spots and some tan spots. It looks like it's made up of many different things. What about this fruit salad with cucumbers and olives and tomatoes, and looks like that's cheese. You can tell it all apart. You can tell where what all of it is. But where's the water? Where's the Kool-Aid? You can't tell that. It's all mixed together. It looks like it's one thing, but it's not. This is a brass doorknob, and it is made up of zinc and copper. Can you tell where the copper is? No. Can you tell where the zinc is? No. It is one thing. It looks like one thing, but if you were to look at it under a microscope, then you could tell. Then you can tell. So, a heterogeneous mixture has different things visible. A homogeneous is evenly distributed, one in another, so that it looks like it's one thing, but it really isn't. So, what is a heterogeneous mixture? A mixture that is not completely uniform throughout. It has layers: salt and pepper, muddy water, oil, and this water's has had some food coloring added to it. Different things visible. A homogeneous mixture has the same consistency or is uniform throughout. It looks like it's the same thing, but it really isn't. How about if you get some salt and add it to water? What do you get? Salt water. It looks like water, but it's not. There's salt in there. Copper and zinc makes brass, and drinking water has H2O and all sorts of other things that don't hurt us. But it looks like it's one thing. That brass doorknob looks like it's one thing. Salt water looks like it's one thing, but it's not. Evenly mixed. Evenly mixed. What is another name for homogeneous mixture? Solution. Solution. So, what do you think? How about this? Can you tell the different parts? Yeah, you can. Hetero. How about this red liquid? What is it? Is it red water? Maybe. It's Kool-Aid water. Can you tell where the Kool-Aid is? Nope. Can you tell where the water is? Nope. It looks like a new thing, but it's not. It's homo. How about this? Is it pretty uniform? Red and blue. Maybe that's pink. Pink and blue, pink and blue, pink and blue. While this looks like it's different layers, doesn't it? This would be homo, and this would be hetero. What are the two parts of a solution called? And what are they? They are solute and solvent. The solute is the stuff that gets dissolved or dispersed. The solvent is the stuff that does the dissolving. It does the dissolving. So in salt water, salt would be what gets dissolved. It is the solute. Water is what does the dissolving. Typically, it's the one you have more of that is the solvent, and the one that you have less of that is the solute. So, solute, solvent. See that? All right, we'll stop it right here.